Valid. Hollow Knight is so valid.
All right. I am going to begin us. Thank you all for being here. It's good to see you all. I see a lot of returning faces. I see a couple new faces, which is super exciting. So really glad you all are all here. We're Ratio Christi, so if you're not familiar with us, we are one of the campus ministries here, one of many. Our focus is Christian apologetics, which is ultimately understanding why you believe what you believe, looking at the evidence for your beliefs, and then learning how to discuss that with others. And that's what we're going to do here tonight. We're really excited about that. We're really excited to have Dr. Polsgrove. He's been here before. I know some of you are back because you've heard him before. He's wonderful. It's always a blessing to have him come all the way up here from the Springs. So make sure to be grateful for his drive and long commute. Dr. Polsgrove has a lot of experience and a lot of knowledge on this topic. If you've heard him, you know that. He got his PhD from University of Minnesota. So he's used to the cold, but we don't have that today because it was incredibly warm, and I think I got sunburned. So, yeah, you definitely got sunburned. Which we got sunburned tabling, so if you're outside while we were whiteboarding and said hi to us, thanks for stopping by. It was a good time. Hopefully we had a lot of good conversations. Hopefully some of those conversations can continue since they were related to the talk today. Typically, you know, if you're emceeing, you're supposed to give like a little icebreaker and warm everything up. I have no jokes nor icebreaker prepared, but I do have something interesting, is that by some scholars, and we just read about this as we were doing a study on the leadership team, it is most probable and most likely that 1,995 years ago, on this day, Jesus was crucified. And whatever time during the day he was crucified, which I don't know, which is interesting. But that's just a historical fact, which I find very interesting, that it's today, April 7th of 1,995 years ago. Which is kind of interesting and kind of strange, but you're going to have to put that one in your pocket and then bring it back out in 2 weeks when we celebrate Good Friday and Easter. So on that note, I'm going to pray us in, and then I'm going to invite Dr. Polsgrove to take it from there. So if you please bow your heads with me. Lord, thank you for today. Thank you for the beauty that you've put us around. I know I so often take for granted all the things around us, and how good you are to let us be in them and live in them here in Colorado. The mountains and the trees and some of the birds we saw strangely close to us on the windows during our meeting. Just what a blessing it all is, Lord. So bless us tonight. Be with us as we hear from Dr. Polsgrove. Help him to speak clearly and effectively. Help us to listen attentively and well. I know there's many things that pull at our focus, and exams coming up, or some people who have exams tonight, Lord, who can't be here. But regardless of all these things constantly pulling at our attention, may we focus in the next hour to hour and a half, learn and engage in dialogue. And may this be a fruitful night where we grow closer to each other and build new relationships and friendships, but more importantly, grow closer to you. So bless all things that we do. In your name we pray. Amen. Here's Dr. Polsgrove.
All right, thanks, Luke. This is going to be so weird coming up here next year. Luke's not here. But I've heard the club is in good hands. No pressure, Devin. Yeah, so he calls me Dr. Polsgrove, but I far prefer Dan or Dr. P as one of my former students. I teach at a high school, and Brian here was my student in astronomy class, and here he is. And first time that's ever happened. And my, I think now 6 years, coming up once or twice a year, I think since 2020. Obviously that year it was over video, but it's really, really a pleasure, and I appreciate the invitation. And jumping on Luke's, kudos for coming here, spending some time developing your faith, especially on national championship basketball game night. Apparently no Florida or Houston fans. I know, I don't care. If my Michigan State Spartans were in this game, I would have might have rescheduled. But they're not. So we're going to begin with, I've got an icebreaker, Luke. Kind of. It's a competition. I call it the pre-presentation quiz. And gives you an opportunity to pull out your cell phone. I know my students love it. Any opportunity to pull out their cell phone. And what we're gonna do, let's see if I can get this to project. Oh, I didn't even know. So I've got, it's called Pull Everywhere. And I'm gonna need help right off the bat. Carl or Donald. We're trying to make just a website show on the screen from my browser. and what it is as we're getting the technology to succeed.
It looks like you've got.
Because the
Oh, let's see. Can you drag it to the right and bring it over to the there?
hey,
Wow, that's what it is.
way to go.
We got it.
Okay, this is a 5-question quiz. If you so choose to participate, which I recognize is fun, and it will let me primarily calibrate the audience on your knowledge of this topic of cosmology and the Bible. Genesis, Big Bang, presentation quiz. Point your device of choice at the QR code. It might ask you annoying questions about registry users website. I just use it because it's free. At some point, you get to a page where you put your name in it, your team name, and you can partner up with somebody. The individual effort is always more exciting. And as the subtitle indicates, there's points involved. So every question has a 30-second time limit. If you answer correctly, like super fast, you'll get 1,000 points for that question. If you answer incorrectly, any time scale, it's 0. But if you answer correctly when you were slow, 1,000 points will slowly go to 0, right, Brian? Is anybody not in that would like to be in? Okay, give me another few seconds. Go ahead, start. To the grand champion of pre-presentation quizzes. They might be just, I don't know if anybody raised their hand, but super into cosmology or astrophysics, or is there seniors? Yeah. Who are anybody major in physics? Okay. Oh man, ringers. Ringers, okay. Better go 5 for 5. There's the 5,000 points. What's your name? What? Ty?
Yeah.
Okay, Ty. 5,000. Right here. Everybody in now? Okay, here we go. Question number 1. In line with the latest consensus cosmological models, most scientists conclude that the Big Bang occurred approximately how many years ago? Very good choices. And the timer is go. Okay.
What if I delete my answer?
You can re-answer. It'll just cost you time. 5 seconds. All right, time's up. The correct answer, 14 billion years, 87% success. I should have expected nothing less from a school of mines.
Who must be in first place?
Oh, it's a huge
So is everybody.
tie for first place.
That's
All right, that was the easiest question. We're gonna start testing you for real. Measuring galactic redshift versus distance. This astronomer is credited with discovering that the universe, space itself, is expanding. Who was that? Kepler, Hubble, Webb, or Sagan? Pardon me, fun is being listening.
25% check.
That's right. No exams this week, right? Somebody's got it.
we have exams all the time.
Oh,
Yeah.
Yeah, it's just never-ending exams.
Never ending.
One this
It's
week.
not even
And
the
then I
spring.
throw
It's not even the spring break. They just assign 2 weeks worth of homework a week after.
Oh, that's cool. That astronomer was Edwin Hubble. Ooh, a little bit lower.
I trust you more.
The namesake of the Hubble Space Telescope. This should have thinned the crowd a little bit at the top. Not much though. Woo. Super impressive.
So we got 1979.
All right, number 3. Keep cranking it up a notch.
Oh yeah.
2 astronomers. The acronym CMB stands for what?
Calcium at this point, yes. Especially in like whatever that.
I did think so. Sounds like for a boundary. It sounds like maximum material.
And time's up. The correct answer is A, the cosmic microwave background. Good job, 83%.
It is 1.4 solar masses.
2 more. Ooh, and then there were 7.
Shame.
On which day of creation in the Genesis creation account did God say, "Let dry ground appear"? God called the dry ground land, and the gathered waters he called seas. Mixing it up into biblical knowledge here for a moment. Eight. It's 8. Yeah, I keep walking away from the podium, but I hope that's okay. 5 seconds left. All 24 people are. That's the max. I can cut it short. It was the third day. Ooh, it's separated. I don't know if the lowest success rate of all 4 questions so far is the 1 month Bible. Ruh-roh.
It was my second guess. My second guess.
Oh, 2-way now, just Alex and Grayson.
Uh-oh.
But everybody's still in it. Everybody's still in it. Well,
Not
Not- one more. In 1998, astronomers studying distant supernovae discovered the universal expansion rate is accelerating. This unexpected result was attributed to blank, which remains a mystery to this day.
This is 4 things I've never heard of before.
Yes! Learning has already occurred. Somebody's still holding out. Oh, there's the 24. Right, if you said dark matter, you're wrong.
Oh!
Yeah, it's dark energy.
That's what my answer
said. Yeah, both of them are just mysterious entities that make up the majority of the energy budget of our universe. All right, the final podium shows. Oh, it was a perfect 5,000 from both Alex and Grayson. Are you kidding me? You too?
Yeah.
That's shocking. All right, you can leave, I guess. Perfect score.
Stick around.
That's very, very impressive, guys. And hopefully a little learning already occurred. We're going to get into the details of this here now. And my goal is to talk at you for a bit, 45 minutes or so, and then if anything's been interesting to you that you want to ask questions about, then we'll talk about it. Very challenged by this computer system. But here we are. So title, Genesis, Big Bang, and no beginning models, what best fits the data? And when I was setting this up with Donald originally, the schedule for this semester had somebody talking about the cosmological argument for Christianity from like a philosophical angle, if you want to say. And then our idea was then I would come in as an astrophysicist and kind of give the scientific angle. And so that's what I'm doing. Here we are tonight. And the connection really comes with clause number 2 in this classic cosmological argument, which if you were here that night, you're familiar with. If not, you're seeing it for the first time. But the second clause says, the universe began to exist. Scientists aren't sure. That's why I put, are we sure? And so that's going to be the theme throughout the whole 45 minutes I talk at you, and then perhaps questions and answers. Sort of motivated by comments like this, which is from one of my favorite authors and apologists, Hugh Ross of Reasons to Believe, who said, if observations prove beyond any doubt that the universe has no beginning of any kind, that would be catastrophic to Christianity. And so this topic has potential large implications for our faith and our witness here in the 21st century. All right, little background about me, just to highlight a real person and why I'm the one talking about astrophysics in front of you. I grew up in Michigan, in the Detroit area, decided to come to college here in Colorado. I went to the Air Force Academy for my undergrad and then was in the Air Force for 20 years as a physicist. During that time, while I was active duty, I got to do a master's at Michigan State and then a PhD at Minnesota. And there's a couple of pictures of me here in Minneapolis way back in the day when I had no gray hair and was wearing those really, really old Air Force uniforms, working on electronics. And then my time culminated in 2009. That's when I graduated, got my diploma. We did a test in New Mexico at a NASA ballooning facility. Underneath that balloon is a huge telescope I was part of building that received millimeter waves and was meant to study the cosmic microwave background radiation. And our goal was to map the polarization pattern in a particular patch of sky, which was intended to either maybe discover the smoking gun of a period of rapid inflation in the early universe or not. And it would have been imprinted by a ubiquitous field of gravity waves, and it never worked because when they flew it over Antarctica a few years later, somebody didn't do the right calculations on one of the motors and it got too hot and it didn't work. So it went going up and down in 7 years and $4 million down the drain, but that's astrophysics research. So nowadays, here's me now. My wife and I were both in the Air Force. Her name's Kelly. We're both retired. We retired in 2018 together. Got a couple kids. Conley's a sophomore in high school, is a big hockey and soccer player. And then my daughter, Elizabeth, also known as Lightning Liz. She is a world champion American Ninja Warrior competitor. That's her in Costa Rica on Team USA last summer, competing in the 100-meter event. She will be in Sweden in September with Team USA again. And there's the four of us in Michigan. And I also have a part-time job working at the planetarium at the Air Force Academy now. I work there a couple days a month. I don't know if anybody's ever been there, but if you haven't, come on down. We have some great shows and lectures I do. Okay, so here we go. The mission for today. As a former military guy, I can't help but use this lexicon. Examine competing cosmological models and assess which is or are most plausible and compelling. Ultimately, was there actually a beginning? The game plan here. Brief history of cosmology, which is important, I think, in motivating the rest of the conversation. Then, evidence for the Big Bang model, aka the lambda CDM, or dark energy, cold dark matter model. And why is it so compelling? Then, the case for a supernatural cause, and the case for a natural cause. Finally, the verdict. What's our opinion going to be? Let's go back in history a little bit. So in 1900, just picked a random year, but that was before Einstein and Hubble did their thing. So in 1900 and the few years after it, the prevailing view of all smart scientists was the universe was eternally old and eternally large in extent. Didn't have a beginning, always been here. And it doesn't have, it never ends. That was it. Now, in 2000, we have a completely different picture. Over that century, research revealed all these features. There was probably a beginning. There was probably a rapid, faster than the speed of light expansion of space itself, way less than a second after the Big Bang. And since then, a much more gradual expansion until recently when the expansion rate has accelerated due to this completely unknown thing called dark energy. And also that because E equals mc squared was posited correctly, energy and mass mean the same thing, they're just two forms of the same entity. Dark energy and dark matter, things we know nothing about, represent 95+% of all the stuff in the universe. That's where we're at. And there's these terms. Lambda, also known as the cosmological constant, represents the dark energy component, the dominant, and the CDM means cold dark matter, so slow moving. Fast dark matter would mean like moving like the speed of light. And today, the only difference between the previous slide and this slide on this diagram is right here. The beginning part is in question or being challenged these last 20 years in particular. And that's relevant to our analysis of the Genesis account. Here's what's not up for debate, at least in scientific circles. All those features that I've made purple arrows point at. We can see the cosmic microwave background to exquisite detail. There was undoubtedly a time before stars formed, then they did. Galaxies, of course, because gravity works on all scales, formed, and then this mysterious dark energy expansion. And we've got this down now at the age of the universe to 13.77 plus or minus, I think, 0.02 is the last error. Not proven but accepted by most scientists because it solves some problems is inflation, more to come. And then the final frontier. What happened before inflation? Was it a beginning or was it something else? The main point of our exploration today. Okay, the first hint of a beginning to challenge that steady state model, the universe is infinitely old. Came in 1915 thanks to that guy I bet you've seen before. He came up with a lot of stuff. Did not win a Nobel Prize for general relativity. He actually won that for the photoelectric effect of work. But this is maybe his longest lasting contribution to the scientific endeavor. And it is the general theory of relativity. That's the ugly equation that I hope none of you have to suffer through in class. Have you, Tyler? Have you really?
Yeah.
Okay, you're gonna have to come up.
I mean, there's some
You might have to
there's
teach
some
this.
physics majors at the school. There's physics majors here, so.
Yes, physics majors. Woo! Okay. For the rest of you, sorry to inflict this on you. But you're at Mines, I was telling Donald earlier, I would never imagine giving this presentation to any other audience than an audience at this Colorado School of Mines. So get ready. It's gonna get crazy. What's crazy is this term. That was not originally there. Einstein added it. So his original formulation was that. Like the mass curvature, roughly. And he invented that middle term because he was so devoted to the universe didn't have a beginning, it has eternally existed. So he added that extra term and called it the cosmological constant, that Greek letter lambda. Okay. This guy, interestingly, a priest, George Lemaitre, somehow you pronounce that, I don't know. Tom Crow, anyway, you can jump in any time.
Any Frenchy, whatever.
Especially. In 1920s, he's really good at math too. In 1927, he said, au contraire, you know, Einstein, your first version was right. The universe probably is dynamic. It's either expanding or shrinking. So it might have had a beginning. Then in 1929, Edwin Hubble, using the then greatest telescope on the planet in California, gathered data looking at what he called nebulae, fuzzy spots on the sky. Even through the telescope, they were fuzzy. But he had no idea there were whole separate galaxies. That was less than 100 years ago. And what he did was he made a plot. This is a very, very famous plot in the history of astronomy. This is the velocity of the galaxy. Every galaxy he imaged is a dot. Really don't know what the circles versus the solids are. That's 0. So, and this is distance away in everyone's favorite unit, parsecs. Okay, parsecs about 3.26 light years. So below the line, any galaxy residing below this line in this plot is moving toward us here in the solar system. And galaxies above the line are moving away from us. He expected, because of the steady state infinite universe model, to see the same number of dots above and below. That's what should have happened. Didn't happen. And in fact, not only are there more up here, but as you go further away, they're higher. Best fit line, we know that as the Hubble law. The natural conclusion is the universe is expanding. If everything, almost everything except the really nearby ones are moved away from you, the whole thing is expanding. That was number 1. Hint, yes, there was the beginning. Number 2, the cosmic microwave background radiation. That was in 1965. So you can imagine, from like 1930 to 1965, there were people on both. You can imagine going to conferences like, no way, Big Bang's false. Yes, it is, it's true. But then in 65, game over. The cosmic microwave background radiation was discovered. It was actually predicted in the 1940s by a guy named Dr. Elfer at Princeton. He said, well, if there really was a Big Bang, then, and the universe is expanding, then the whole place should be getting cooler and cooler and cooler all the time. And thus it would be emitting some radiation all over the universe. Sure enough, these guys, they're in New Jersey at Bell Labs. They're trying to work some experiment. It has nothing to do with astronomy. They can't get rid of this stupid signal that's messing up their experiment. And they're like, wait a second, I think I've heard it. I think somebody might have predicted this. Sure enough, guess who gets the Nobel Prize? Those guys.
They thought it was bird poop at first.
Right.
That's right.
Yeah.
They did clean the pigeon droppings off the inside of that satellite or that antenna, hoping that would get rid of the noise. They got a Nobel Prize to thank for that not being the case. Years passed, we're in the 1980s, and NASA launches the COBE satellite, and it confirmed the 1965 discovery with a telescope in space. So no noise, don't have to mess with the atmosphere or anything. And indeed, so the prediction, I love this plot, it's weird units. Megajanskis per steradian is second to parsecs, everybody's favorite unit, of course. and then wavelength of light or frequency. And so the prediction, if the universe really did have a beginning, and it's really been cooling for 13.77 billion years, then the red crosses should land exactly on the blue theoretical line. When the red crosses came in after the analysis, that's what happened. Perfect match. So when that was presented at conferences, nobody could live in the past and be like, the static model, the infinite universe is true. That was like over. So that was an amazing experimental work. This is a map. You might be, if you're familiar with the term cosmic microwave background, you might be used to seeing something more like this. It's just like a map of the Earth, trying to make something spherical into a oval. That's the whole universe. The red and blue just means slightly hotter and slightly cooler patches. And I mean, by slightly, I mean like 1/100,000th of a degree Kelvin. Tiny, tiny little differences in temperature. By and large, it's all the same temperature everywhere, which is what the Big Bang models predict. Okay, so that was number 2. Number 3 didn't happen at one particular time, but it was a natural outcome of the Big Bang theory that in the very early times of the universe, right after the Big Bang, in the first few minutes, the universe would have cooled down enough that quarks could then stick together and make protons and neutrons. And then they could have made the nuclei of some very light elements we know as hydrogen, helium, just a little bit of lithium, nothing else. Sure enough, now with tons of measurements of galaxies and clouds and stars and everything, here's the actual answer. 75%, well now it's 74% hydrogen, 24% helium, and 2% everything else. Like your whole periodic table, everything past right there is now known to come from supernova. So all those elements are created in the core collapse of massive stars that blow up. And those energies and temperatures are enough to fuse nuclei into heavier and heavier elements. And that's what we got. So 1, 2, 3, pretty hard to challenge. But there was a problem. There were problems with the standard Big Bang model. The CMB being everywhere and the universe is flat. So there's the first Kobe 1990 version of the CMB map. Then another few $1 million were thrown into making another satellite called WMAP. They got an even more exquisitely precise version of the cosmic microwave background in 2006. And then more recently, the Planck satellite got the best one yet. So with all those more precise measurements, the story stayed the same. The universe is 13.77 billion years old. But the size of these patches now came into play. Once we could detect them and measure them accurately, the whole universe could be closed on itself or open like a saddle or perfectly flat, space-time itself. If the patches were really big, that would have said, oh, the universe is closed. Like gravity's going to win and we're going to end up in a big crunch. If it's perfectly flat, we get this size of blue and red patches. And if it's open, then we get tinier patches. And the data showed it was this, like the perfect middle answer. Like you have an infinite number of possibilities of bigger patches, smaller patches that happen to be like the exact right flat, which is weird for cosmologists. When that came out, they're like, don't like it. Don't like answers that are super unlikely just by natural consequences. And the flat geometry was confirmed by a balloon-borne experiment called Boomerang in 2001. How could it be flat? Freaked people out for a while. Well before the Boomerang data, the Kobe data, the concept that it might be flat was addressed by Alan Guth of MIT, who proposed this addendum called inflation. The standard model to that point of 1980 just said, the universe starts and it has this expansion rate. This is time, this is the size of the universe. Standard. He said, what if it was super tiny and then for just this blip, that's ridiculous numbers, right? 10 to the negative 35th, 10 to the negative 33rd second after the Big Bang is not even something we can understand, really. He said, well, it was super small, but then our little patch of the universe got super big. And then there was normal expansion rate. That actually solves, and that could be 17 more talks, this one slide worth of material, obviously. But it solved the three main problems of the standard Big Bang model at that time, which was, it explains why the CMB temperature looks identical everywhere. And we thought that we would see some patches of the CMB map and it would look totally different. There could be totally different laws of physics because that patch of universe that's now 12 billion light years away should have had no causal contact with ours in the beginning and could have totally different fundamental constants. But they don't. It all looks the same. It's called the horizon problem. Number two, it explains why we haven't detected any magnetic monopoles in the universe. So weird particle physics, not my realm. Anybody doing particle physics?
That's my specialty.
Are you serious?
Yeah.
Next year, Donald. Bring it back. We can do this talk better, I'm sure. So there should be quadrillions of these little magnetic, so think of a magnet, but not with the north and south pole. I don't get it. Totally admit. But there aren't any. We never found them. And it explains our measurements of the geometry of the universe being flat. So it solved the flatness problem. Big whoop. Who cares about flatness? Well, it's because, like any generic universe, more likely than not would be either open or closed based on the amount of matter in it and these weird concepts of dark matter and dark energy. But you would, even if the universe really is one of these geometries, if it's super huge, just like the Earth, if you stand here on the Earth, like many of our ancestors did, they're like, well, this place is flat. It's just because the whole thing is so huge, it goes beyond your perspective. So we could just be able to observe a small patch of a way larger universe, which some people call the level 1 multiverse, and we're just, it's unmeasurable, the curvature. Only 13.7 billion years after it began. So it has a lot of, this flatness issue has a lot of implications later in the talk and beyond the talk. We'll just leave it at that for now and move on to kind of the second phase, which is, okay, the case for a supernatural cause. We're here at Christi. This is the mission. So biblical scripture appears to repeatedly describe the two most prominent features of Big Bang cosmology. At least I'm convinced by this. Others are not, of course. But I'm going to make the case for this. The first one being the main topic tonight. A beginning. The emergence of all space, time, matter, and energy ex nihilo, or out of nothing. Sometimes if you're into this, you'll see this term ex nihilo in Latin, I guess. Meaning literally nothing before it. None of those four quantities. And here are just a handful of some of the biggies from the Bible, from different books of the Bible. In the beginning, God created the heavens and the earth. Bet you knew that one. There are others that are conveying the same thing by different authors, also inspired by God. By faith, we understand that the universe was created by the word of God, so that what is seen was not made out of things that are visible. That's in Hebrews, the New Testament. As it is written, I have made you a father of many nations, in the presence of him whom he believed, that is God, who gives life to the dead and calls into being things that do not exist. Oh, it's the Apostle Paul writing that. Finally, you are worthy, our Lord and God, to receive glory and honor and power, for you created all things, and by your will they were created and have their being. Going back by the Apostle John in Revelation. It's all over the place. Number two, this one will be a little more controversial. The second is making the connection between scripture and observation scientifically, which is expansion, the universe expanding. The term stretching out occurs in a bunch of places. I'll give you a handful. In Job, usually taken to be the first book chronologically ever written in the Bible, he alone stretches out the heavens. From Isaiah, he stretches out the heavens like a canopy and spreads them out like a tent to live in. From Psalms, the Lord wraps himself in light as with a garment. He stretches out the heavens like a tent. And a fourth one from Jeremiah. But God made the earth by his power. He founded the world by his wisdom and stretched out the heavens by his understanding. The four different authors, using the same phraseology of stretching out, could have different meaning. Certainly many scholars have posited there's different meanings for that phrase stretches out. It would just be a coincidence then that now in the 21st century, the discovery was made by modern telescopes that the universe is stretching out. So then there's the connecting it with a previous talk here, the philosophical support of the absurdity of infinity or infinite regression that perhaps was discussed. And if you didn't get enough of it, just Google William Lane Craig and go nuts. Got a very famous book called Reasonable Faith, and I just heard a maybe less famous but great book called On Guard. Is that right, Don?
Yeah. Okay.
So if you'd like to brush up or learn about that lane, then check that out. The scientific support for there being an actual beginning and validating the supernatural cause comes from a couple places. Here's some really famous names of scientists. Hawking, you may have heard of. Penrose, perhaps, Roger Penrose and Stephen Hawking. But then, maybe last, there's Guth, the inflation guy. And then Borda and Vilenkin are very famous cosmologists as well. This started with Penrose and Hawking in 1969 when they're just math nerds, right? They just sit at their desk and they nerd out about theories. And they were, at that point, even said, a universe that's expanding, the past space-time trajectories are incomplete. That's the language they would use, which is just a fancy way of saying there's a singularity and this had to have a beginning. This probably had to have a beginning. So scientifically in 1969 that happened. And then later in 2003, these three heavyweights chimed in and said, even without the constraints that Hawking and Penrose inflicted on themselves in the 69 version, any universe expanding on average, even a multiverse, will have a past incomplete history of space-time trajectories and must have a beginning. So that's only 20 years ago. And that still stands and convinces both theists and some non-theists it probably had a beginning. And if there was a beginning, it's not a huge leap to say there was a beginning. All right, here's the quick aside. I call it the elephant in the room. Potentially. And it's the young Earth creation versus the old Earth creation model. I gave a talk primarily on this a couple of years ago, I think in 2022. So if you're not familiar with this, there are two predominant views within the church today and for a long time of rejecting an old universe, like a 13.77 billion year old universe, in favor of an interpretation of the Bible that would be the universe is only 6,000 to 10,000 years old. So that model would be the young Earth creation model. The OEC, or old Earth creation model, is we're convinced that the Big Bang data is true. The universe is a few billion years old, and that is not incompatible. So it is compatible with the sequence and the report in Genesis and other creation accounts in the Bible itself. I found this would be very interesting. So a 2024 Gallup poll, so just last year, these polls are always done about evolution, but it's not hard to then just translate it into the like old Earth, young Earth thing. So this one specifically, you kind of see the categories and the lines if you are interested and want to digest that data. But the green one's kind of the most interesting. Maybe 37% of Americans would hold that, yeah, I think the universe started about 10,000 years ago. And of course, they would be the ones that would reject the standard Darwinian evolutionary model as well. Another poll I've looked up said 60% of Americans claim to be Christians. So take that or leave it. But if you do, it's pretty simple math. If you combine those two data points, it would suggest that right around a little over 60% of Christians prefer the young Earth model. So the issue with that, and me standing up here talking about 13.7 billion years old, is that everything I say is totally irrelevant from the young Earth creation model perspective, essentially. So today's presentation inherently condones or accepts the old Earth model if we're talking about a beginning 13.7 billion. So whatever, that's just maybe a topic for discussion in the question and answer amongst you guys at some point. A quick, you can probably guess, I mean, I am more convinced by the old Earth creation model and its consistency with the Genesis account. So take it or leave it, a brief overview of that model, why I think that the OEC is the best fit with nature and scripture. So in 2 minutes, the 2-minute drill of the old Earth creation model, they would say that Genesis 1:1 covers the first like 9 billion years of history. Like in Genesis 1:1, it's saying God created the heavens and the earth. And we've got radiometric dating of meteorites, Mars samples, lunar samples that all date to about 4.5 billion years ago. I find that evidence compelling that the solar system formed about 4.5 billion years ago. That's the point where Genesis 1:2 comes in, where it says, now the earth was formless and empty, darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. Famous verse. It's a weird verse to be in there unless it's describing a new perspective from which the days of creation are now going to be described. So say the old earth creationists modelers. And scientific simulations now show that the early earth probably was a water world covered with water, and it probably had a very thick, opaque atmosphere. The atmosphere was very different than today. So there, you could interpret that as consistency between the setup in Genesis 1:2 and scientific simulations. So the word in the original Hebrew that's been interpreted in English Bibles today is the word yom in Hebrew, and it actually has 4 literal meanings that are used throughout Genesis in the Old Testament. And one of them is like 12 hours, daylight. One of them is an actual 24-hour day. Another one is like generation, and another is just any finite period of time, like day of the dinosaurs. So if you're, to apply the day of the dinosaurs type thing, then the days, the yoms, would be eras. And in the first era, the sun was already there. It was making it through this translucent but not transparent atmosphere. And there was light parts and dark parts as the Earth was rotating. Number 2, scientific simulations show at some point the atmosphere changed. And both clouds with not clouds below it occurred. And also plate tectonics kicked in. And you got land and oceans, which were not there originally. Yom 4 is that's the most controversial one because some read as the sun and moon were created then, but some others in the old Earth camp will translate that to mean the sun and moon were revealed for the first time, could be seen from the surface of the Earth. Is a more natural translation of that word used in Genesis. So they become visible, and you can mark days and nights. You can see the stars. Then 5 and 6 go into biology. Have you already done a talk on this semester?
Not on this.
No, but on the biology and evolution. Okay, so we'll leave that. The chronology of events is quite similar in what types of vegetation and animals come. And for the older creationists, day 7 is still going. We are in it. There is no description of evening or morning in the Genesis account when it gets to day 7. And so that's the period of time that is going on now. All right, there's old Earth creation. Well, probably more like 3 minutes. A lot more on that. Maybe next year, Don. Leave that one. Okay, here's the case for a natural cause. This is where it's going to get really technical. I hope you're ready. It's got an exam tomorrow. Maybe you shouldn't cram this in your heads. Now let's do it. Sorry. There are many cosmological models that have come up over the last 50 years, maybe a little more, that range from insane to maybe. That's kind of plausible. So going from craziest to maybe less crazy. Steady state theory, cyclical models, the no boundary proposal, and quantum fluctuations are a universe from nothing. Let's do it. Steady state model was very popular soon after the Big Bang model was first proposed. It was the first attempt to hold on to the infinite universe. And pretty much said, okay, the universe is expanding, but matter is continuously being created to fill it in, so it's all going to look uniform no matter how far back or how far away you look. Popularized in the 40s by some famous astronomers at that time. One super famous guy, Sir Fred Hoyle, he's actually responsible for the word Big Bang. He was using that term disparagingly on a BBC radio broadcast in 1948, and it stuck. He didn't believe in it, but he came up with the name. So you can kind of see neutrons. His model was like, you can't add charge to the universe, so it's a bunch of neutrons just spontaneously pop up into the universe. That could be verified or denied experimentally. First, it totally denied. It's a problem with the whole energy or matter cannot be created or destroyed part of the laws of thermodynamics. But then also, by 1970, we had observations of quasars, which we were looking back at them 10 to 12 billion light years away, and they were way more packed in. So that was like, yeah, the universe is not static. And then the CMB, the universe is cooling down, obviously, that destroyed the steady state model. Bye-bye.
And
Okay.
no evidence of young galaxies.
No, that's right. Yes, no evidence of young galaxies. Good point. Okay, cyclical models. The religious connection here is that you're probably familiar with terms like karma and reincarnation. They're staples of Buddhist and Hindu cosmologies and religions. So a bunch of cosmological models from the scientific angle of, I don't know if practicing Hindus and Buddhists came up with these. I know in some cases that's not true, it's just scientists. But saying, the universe bounces. We see a big bang, and then it expands, and then it shrinks, then it big bangs, and that's gone on forever. The problem is, that was pretty quickly noticed, this fatal flaw with this type of cyclical model, is that entropy has to increase every cycle. So every expansion goes longer and longer, the universe goes each cycle. So looking back in time means each cycle shortens, and eventually you're back to the beginning. Can't get away from it. Plus, for gravity to win and to close back down, it must be a closed universe, and the discovery of dark energy in '98 kind of dispelled that notion. Double whammy, sorry, that cyclical model. But there's more. How about brain theory? Has anybody studied brains? BRANES? I haven't. And after I did this research, I'm like, and I don't want to. It seems pretty nuts.
I know what brains are because they've been used several times in various cosmic horror pieces. You know,
Yeah,
it's just hard. It's just hard science enough to sound realistic, but just fictional enough to give it scary implications.
That's right. Now here's a scary implication. If brains, which are like universes of their own, were to all exist in different realms of this uber space and smacked into each other, they could create new universes. That's about it. You can see the pictures, they're pretty. No evidence, no empirical evidence validating or disproving this. It's another theory that's just out there. They're a little better because in the math they somehow avoid the entropy problem and don't violate that board goof, the Lincoln theorem about the singularity. Here's another one. This is Roger Penrose's favorite. He calls it conformal cyclic cosmology. A little twist on this. The universe expands forever until all the clocks are destroyed. That's the way he presents it. Which means so not even a single particle with any mass can exist. Eventually it's just like absolute zero. When that happens, boom, the next Big Bang occurs. I'm sure you could go read his papers to understand or not how that happens. This is the overview, so you are aware if you ever run into somebody who's a fan of the Penrose conformal cyclic cosmology, you can say, I think I saw that one time by this dude from the Springs. So it successfully explains how low entropy the starting state is, because there's nothing, it's at absolute zero. But it does predict some like rings in the cosmic microwave background images, and Penrose claims to see these, apparently, or did at some point, and nobody else sees this evidence. It's a shocker, right?
So worse, trust me, bro.
Yeah, just trust me, bro. Alright, now a little bit up the ladder of plausibility, perhaps, is the heart of Hawking, Stephen Hawking back in the game. It's called the no boundary proposal. It requires M theory. It's a version of string theory. The net energy of the universe is zero, and quantum mechanics works in the absence of anything. Here's the quote. In the early universe, when the universe was small enough to be governed by both general relativity and quantum theory, there were effectively 4 dimensions of space and no time. That means when we speak of a beginning of the universe, we are skirting the subtle issue that as we look backward toward the very early universe, time as we know it does not exist. Yeah, just kind of rounds off the universe. Just 4 dimensions, no time. Let's see what's in this box. That's just an example of, like, it's a bunch of words that you and I read it as kind of an expert in this field, like, Okay. Because gravity shapes space and time. It allows space-time to be locally stable but globally unstable. On the scale of the entire universe, the positive energy of matter can be balanced by the negative gravitational energy. And so there's no restriction on the creation of whole universes. Perfect segue to the final promise. No more of this insanity. The final no beginning model. Or actually, this one does have a beginning, but it wasn't God. The Vilenkin-Krauss, there's Vilenkin from BGV, and Lawrence Krauss, who's a very outspoken atheist and, atheist. He wrote a book called A Universe from Nothing. It got really popular. I read it and picked up the following for your enjoyment. Baseline is there are two confirmed facts that motivate this model. Does anybody have to take quantum mechanics? You have to? Nobody else yet? Yeah. Love that. Oh.
Goes in
I'm gonna
one.
take like 3 semesters. Magic, right, Tom?
Oh yeah.
Pure magic.
Oh yeah.
But
QFT.
experimentally verified, at least this aspect of it, that like virtual particles do pop into and out of existence on incredibly short time scales. It's measured. There's these things called the land shift and the Casimir effect, and it doesn't violate the Heisenberg uncertainty principle because of the rapidity with which these actual particles exist and then don't exist. And if a universe is closed, it will have an overall net energy of 0. The negative gravitational energy associated with galaxies cancels out the positive energy from motion and E equals mc squared. That's apparently, both of those are like 2 thumbs up. If those are true, then just like at virtual particles, it's plausible that a closed universe could spontaneously pop into existence out of nothing. No space-time energy or matter. That would not violate the first law of thermodynamics because there's 0 net energy. Okay, 2 for 2. Because they're closed, most will expand and collapse and disappear rapidly. You'd never notice. They would have nowhere near enough time to generate galaxies and people eventually. However, if a period of inflation occurred fast enough, that universe could grow so huge that it wouldn't collapse. It would stick around. And since the net energy is 0, it won't violate Heisenberg uncertainty principle still. Finally, it would have to appear flat. That type of universe would have to appear flat because inflation occurred, and even though it's actually closed, it would appear flat to anybody, especially just a few billion years after it started. And that's what we measure in the CMB. It's famous for saying nothing is unstable and nothing always produces something. There it is. The implications are we're definitely in a multiverse. Yeah. In fact, even theistic cosmologists will kind of concede we're almost certainly in a level 1 multiverse, which means there are more galaxies and stars beyond what we can see with our telescopes today. In fact, tomorrow we can see 1 light day further into the past and can detect more of what's out beyond the quote-unquote edge of the universe. But the Vilenkin-Krauss thing says there's probably level 2 multiverse, meaning separate universe, potentially with different initial conditions, constants, and spatial dimensions, but the same laws of physics. So there's, I don't know, he loves the word plausible. Krauss does. If you're ever to read his book, plausible, 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 plausible everywhere. Okay, given, get quantum mechanics, inflation makes this plausible, but definitely not provable. It's an option. So the strongest challenge with this one is that it requires the pre-existence of the known laws of physics. If it's quantum mechanics that is responsible for the mechanism that brings the universe into existence, quantum mechanics is a thing. The laws of physics are not nothing. And that's where he gets the most criticism. It's not really a universe from nothing. All right, wrapping it up here. Naturalist models seek to avoid a beginning and or an external cause for the existence of our universe. So what they are, not intentionally attacking, but what they're inherently attacking is the second clause of the cosmological argument. The universe began at least the steady state cyclical models and no boundary proposal. You can bin those all into there wasn't actually a beginning. And then the uniqueness about the Vilenkin-Krauss universe out of nothing model is it doesn't have a cause. It's a natural mechanism. You don't need God. Big Bang happened, but it can happen just by quantum mechanics itself. So here's the verdict, in my opinion. Competing cosmological models challenging Genesis and the Big Bang. Do they succeed? You could probably guess that was going to be my conclusion. I'm here at Ratio Christi talking about cosmology. But to rank them, this was Donald's idea, I think, back in 2020 when I first gave this to the group. Steady state model, garbage. Cyclical models, again, this might be useful. These ones might be particularly useful if you ever encounter Hindus or Buddhists who are scientifically literate. Because cyclical models are required, essentially, in their cosmologies. Arlo Hawking no boundary proposal, it's super creative. It's a little bit up the scale, and then that, if somehow there was quantum mechanics in a nothingness that occurred before the universe, it's the closest to legit, but the Borg, Guth, Vilenkin, Hawking, Penrose, there was a singularity, there was a Big Bang. This really did emerge from nothing, and God did it. I think that's by far the most compelling. And ultimately, there's no indisputable evidence proving a supernatural first cause. There has to be an element of faith. There is also currently no indisputable evidence proving any naturalist cosmological model. They are exercising faith as well. They would never use that terminology, but for sure, that's what's happening. So where does that leave us? I think, take this or leave it, I think people who are at least open or already committed to a theistic worldview are likely to accept there was an actual beginning and attribute it to a supernatural cause, as described in Genesis. I think this one better satisfies Occam's razor. If you're not familiar with that, it's just like the simplest solution to a problem is most likely correct, the least complex. And then also the BGB theorem stands tall, still, at least in many circles of professional scientists. But people with an a priori disposition or commitment to an atheistic worldview, they can't go this way, right? They gotta choose one of these other naturalistic cosmological models to be a fan of if they're already dismissing the cosmological argument. So they'll prefer one of those models and maybe a level 2 or 3 multiverse. So both options are defensible with the data we've got available in the scientific realm, and it's your choice. I'll leave it with this. There is huge value, I think, in studying the natural realm. I think you came here. You must think the same thing. You're going to school at Mines, right? Many of you, it sounds like, are majoring in physics and a lot in engineering probably too. So in Psalms, amongst many other places, God has inspired, in this case, King David to write down, pay attention, look up. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge. This is a worthwhile endeavor and believable. It's another form of revelation, scripture and nature, and they have to be consistent if our worldview of Christianity is correct. And then maybe my favorite one about the beginning is from John, right off the bat. In the beginning was the Word, and the Word was with God, and the Word was God. He was with God in the beginning. Through him all things were made. Without him nothing was made that has been made. That's that. I've used a couple. The main books that I use, one is from a Christian apologetics perspective called The Escaping the Beginning by Dr. Jeff Swearing, and then that book, A Universe from Nothing from the Other Side by Lawrence Krauss. And at times in the past, I've had students be interested enough to actually email me, maybe with a question. We don't get to talk for the last 20 minutes officially devoted to Ratio Christi time tonight. But if you want to, go ahead and write it down. Had a couple of really fun dialogues with former students. And that's it. That's all. Thanks for listening. Anybody's brain plastic? We'll find out. Okay, I threatened there would be a post-show quiz, didn't I? Oh, I might have forgot that part. Here we go. Okay, get your phones out. Get ready. Let's see. We know it was, who was it, Alex and Grayson that won the first round? Yeah. There you go. Can anybody take down the dynamic duo in the back. What'd you get? What was your score?
Brian failed.
Brain cells dumped. Was it just last year? Was it just last year? See my classes from last year, it was 2,000, 5,000. To his credit, it's the class about the solar system, so we didn't get much cosmology. All right, anybody not in that wants to be in? Okay. Give me another minute. 10 seconds.
Three questions.
Three questions? Just three. So you got to be good quick. Question number one. This theoretical phenomenon added to the original Big Bang models in the 80s is unproven but compelling to most scientists because it solves the horizon flatness and magnetic monopoles problems. Is it energy, cosmological constant, inflation, or cyclical cosmology? Oh, we got 25 players. All right, the correct answer is inflation. Ooh, 2/3 success, 1/3 failure. All right, let's see what the leaderboard looks like. Oh, it's a huge tie for first. Dot. Yeah, it's Dot. What a clever name. Okay, number two. Most old Earth creation proponents accept the consensus Big Bang model and hold that Genesis 1:1, in the beginning, God created heaven and the earth, describes the first how many years of our universe's history? 400,000, 500 million, 4.5 billion, or 9.2 billion years? Ooh, there's number 25 is in with 10 seconds left. Okay. Didn't think you're gonna have to do math during the meeting tonight, did you?
3,000 billion.
It's 9.2 billion. Yeah, from the creation event at 13.7 to the solar system formation at 4.6. That's where I got that math. Way to go, 60%. I didn't expect that higher rate. Good job. You got that one. Oh, and now we have 7. 7 tie for first place. I gotta make these harder next time, Doug. These are too easy.
Who did that?
Let's see if they win, and then we'll make sure they expose themselves. Number 3, the most compelling and thus probably correct cosmological model presented today by me is which one? Vilenkin-Krauss, cyclical models, Hawking-Hartle, the old Earth creationist model, the young Earth creationist model, or none of the above? You got some other idea? You find most. Seconds left. For all the marbles, 2, 1. The correct answer is
Don't say all
all of them.
Oh.
Or none of them. That was kind of a trick question. I marked them all correct because it's your opinion. There is, like I had on that last slide, there's no indisputable proof of any one of these. This is really just a survey I wanted to wrap this up with to see where this group is. And this will probably inspire some conversation here now or in the future. So, interesting. So we got a couple, the 2 naturalistic models that are most compelling to 1 or 2 of you, and then old Earth and then young Earth, and nobody has any other ideas. Come on, where's the creativity? We covered a lot. There aren't a lot beyond what we presented today that have much popularity. So, okay, interesting. That's really the end. That's where my water
These are the results.
We gotta see the final.
Yeah, let's see how
We
Donald.
gotta see if Don or Donald's better half. Oh! It is Don. And Alex goes 2 for 2. And Jones kill.
Well, I mean, the two of us.
You teamed up?
Oh,
Two brains. I don't know if that's legal. Yeah, that last one obviously just came down to speed. Whoever was fastest got full credit because they were all right.
So I got 23rd, 24th.
Okay, Luke, over to you.
I'm gonna hand it off to Grayson.
Hey, Grayson.
Oh.
Woohoo.
Son of Ray.
Oh, I don't care. You guys are in charge.
Wait,
No,
I'm
I
here.
was
I'm here.
Luke
Yeah.
Duke.
You want to do group Q&A if anybody's got a
Very
question.
handsome.
How do you feel about it?
So you wouldn't.
Grayson closing us out with a few announcements, we'll pray out, and then if you want to stick around for a few minutes and see if there's
That's
questions,
what I
and everyone wants to engage. Perfect.
Love it.
Alright, first off, I feel like I should probably introduce myself because I haven't been up here before. I'm Grayson, and I'm the incoming Ratio Christi secretary, so I get all the work that no one wants to do. I just have a few announcements to make. First off, we have these Ratio Christi stickers. If you want them to put on your water bottle or computer, or I don't know, wherever a sticker can go. Yeah.
Red, whatever.
Then yeah, afterwards you can just come up and grab one. We have plenty to go around. Second off, the talk next week, I believe we have Bill Hasenberg. Hansberger. I have most of the letters right. Hansberger coming in, and he's giving a talk on the resurrection because there's I think there's a holiday coming up that celebrates that. And let's see, I know Luke has something to say. I'm assuming that maybe after we pray.
Y'all do it right now. I know I said I was giving it to Grayson, but I lied. April 25th. I've mentioned this before, but mark your calendars and save the date. No one's getting married, but it is a very, very important anchor. So be there for the anchor. It's going to be kind of our big finale for the semester. A lot of us ministries are coming together to host it together. We want to put a lot of effort into this, and so we're really hoping you guys show up. We want it to be a blessing. It's going to be a time of eating dinner, having fellowship, catching up with people about the semester, about the year, things that God has done, the things you've been learning. It should be super duper duper valuable, so I really want to highly stress April 25th, reserve that evening so that you can come and hang out. We're going to have students sharing testimonies, student speakers. Did I mention food? So be there or be rhombo-decahedron or something of the sort. Sound good? Save the date. Thank you.
And one more announcement that I forgot. If you're new and you want to sign up on the email list or the groupie that we have, just talk to Donald and he'll get you hooked up. That's going to be my job soon, be the secretary. But for now, it's still under his jurisdiction. And without further ado, I'll pray us out, and then yeah, we can have Q&A, and then you're free to go. All right. Dear God, thank you for just letting us all be able to come here together and just learn about the universe that you made and just how wonderful it is to be able to study the creation that you've given us. I pray that we use this knowledge to just have plenty of good conversations in the future and to just show how science and Christianity can coexist, and that you made our brains rational to be able to understand you. And I thank you for just doing that and being present in our lives. In your name I pray. Amen.
Amen.
One other thing that's really important is that somebody in this room has a birthday today.
Oh my goodness.
Today?
Is it a student or it could whoever's birthday it is stand up so we could sing?
Happy birthday to you. Happy birthday, dear Heidi.
Or Julia's mom.
Happy birthday to you.
You're always bringing us baked goods.
It's true. It is a
It convinces why people come back.
Only reason.
That and Dr. Fogg. Alright, thank you for being here, everybody. Eat the rest of the snacks, and hopefully, time to ask some questions and have some good dialogue.
Yeah, let's go.
Right.
Learning.
I've had a lot of questions about. I've had a lot of questions about like, oh, I think that's I don't have any good descriptor. Some people are like, I think they're just like a laugh.
I don't trust anybody else to forget about an announcement and remember last second. Oh wait, what?
Especially like the sick room where it's like entropy tests to increase. Lower.
Yeah, every